Hi guys, and welcome to oldschoolhaunter for another project in the world of digital decoration. During the Christmas season, a Christmas calendar is running on my window as a digital projection. Every day a new door opens automatically and different projections are played. Between each video there is always a 1-minute waiting period until the next projection starts automatically. Now 1 minute can be very long, and especially with temperatures below 0 degrees Celsius, the waiting time seems to be twice as long. So I thought to myself, hey, why not let the kids open the doors themselves? And so the idea of this control unit here was born. It includes 24 buttons, so one button for each door of the Christmas calendar, and to be honest, children love to push buttons. I've also waited with this video until Christmas is over, because at the end of the video I wanted to share my conclusion about this project here. So if you like the project at the end, please give me a thumbs up and don't forget to hit subscribe. But now enough for the introduction, onto the project and let's go! So alright, the whole project starts with this pine glue laminated board and this left over here because the pine board isn't enough at this point. And here you can take a look at the sketch, and here we'll have a box at the end with a width of 40 cm, a depth of 30 cm and a total height of 45 cm, and at the top you will have a plexiglass to cover it, and here's an open space, and at this point you will have the panel for all the switches for the single calendar doors. So let me cut the pieces quickly and then we will see again. So right, I'm done with cutting all the wood, and yeah, that's pretty much it this time. And here you have some support slats which I need on the inner side, and let me show you a small detail here on the side parts left and right. The side parts get an angle cut at the top because the plexiglass later on will be put from the top, and so the water can run down. I add an angle cut here. So as next step, I will assemble the box. So right, I'm done with the box. Here it is. And now it's time to add the switch panel, which will be placed in between here. And here's the panel. It is an aluminum compound panel this time. And as the next step, I will add all the 24 holes for the switches which control the doors of my Christmas calendar. Alright, this will be the control panel, and here we have the push buttons, and the push button has a diameter of 18 mm and the hole for the push button has a diameter of 12 mm. And those 24 push buttons will be placed in 3 rows with 8 push buttons on each row. Alright, push buttons are in, and now it's time to wire everything up. The whole system is controlled by an Arduino at the end, and I found a very cool instruction how to connect so many push buttons to an Arduino, and the instruction is taken from the DIYlife.com, and I put the link for the website down in the description. And yeah, at the end it looks like this. You have some resistors here connected in series, and those are the same resistance. And if you close the circuit here by pushing a button, the resistance is measured by the analog input of the Arduino. So this is how I wire everything here. And as resistors I use those ones here, 220 ohms. And because it's very experimental at this point, I use those vacuum nuts to connect everything here. So alright, I finished the wiring, and yeah, it looks like a mess, so sorry about it, but it's very prototyping at this point. If it works the way it should work, I will create a separate printed circuit board, so all the wiring will get a little bit better here. But for now, I use some adhesive strips to attach the vacuum nuts to the board here, so we don't hang around. And if you follow the wires from the push buttons, we have the Arduino. It's an Arduino Uno R3, and here we have a Wi-Fi module. It's the ESP8266, which is attached to the Arduino, and this Wi-Fi module will send the data from the Arduino to the player, which controls the Christmas calendar. So here we have the normal circuit, the positive and negative, which goes all through the buttons, and here we have the data line. The data signal will go through this line. If a button is pushed, and this data line is attached to the analog input of the Arduino. And here we have two additional status LEDs, one for Wi-Fi connection and another which simply indicates when a button is pushed. I will create a separate video about the programming of the Arduino. It's not so much, but it's too much for this video, so please check you are subscribed to the channel so you don't miss this follow-up video. And for now I will take all this and place it in the box. So alright, back at the box. Because I use the box outside, so it sits in the rain and snow, I have to give it a paint here. And this time I used some boat paint here, which is known as weatherproof. And I use a green color here, which I think pretty much fits for Christmas time. So right, we are nearly finished, but before I can put this thing to the outside, I will add some plexiglass to the top, and this sheet of plexiglass makes sure that the water will not fall down here. And it's 4 mm thick here, and to attach the plexiglass I will use such plumber screws here, and those screws have a sealing ring, and the sealing ring makes sure that the water will not flow into the screw holes. So alright, this was the making of my control unit for the digital Christmas calendar. At least the prototype when we talk about the wiring here. The case itself is already in the final state. I have to admit this is a very demanding project because the interaction of the many individual components has cost me many sleepless nights. The construction of the case itself is still rather the smaller part of this project. Most of the time was needed to build the electronics and do the programming. Also, the measuring of the different values for the resistors took a lot of time, and the fine-tuning at the end was also very time consuming. But how well did the whole thing work during the Christmas season? Well, everything in itself worked quite reliably. There were some problems with the good old Wi-Fi connection. Sometimes the values of the resistors of the press button were not correct, so the from video was played. And sometimes the call to the video player couldn't be executed, although the Wi-Fi connection was available. That the values of the resistors fluctuate a little bit at this point is surely due to the wiring using the vacuum terminals. I already had slightly different values during my tests beforehand, just because I moved the cable a little bit in the terminal. So at this point I think this can be solved pretty well if the wiring is soldered properly. The Arduino script also needs a bit improvement so that it is more robust when the connection to the video player is broken. This is certainly the problem, that the video player was sometimes unreachable and thus pressing the button didn't do anything. But in the end I have to say that despite all these problems I'm very happy, because for me it was also the first project of this size with so much electronics and the programming. So in the end I'm very satisfied and I'm happy that I did this project. I'm definitely creating a separate video where I'm going more into detail of the technical aspects of this project. That would have been too much for this video here. So we've reached the end of this video, and if you like the video, if you like the project, please give me a thumbs up. If you have questions or suggestions, please write them down in the comment section, and don't forget to hit subscribe so you don't miss any of the following updates. So for today I say thanks for watching, see you next time, and I'm looking forward to the next projects.